Welcome back to Bot Thoughts by AmTalkSoft. I'm Alex. Today we're getting into a debate that has been running hot in AI engineering circles since Gemini 2.5 Pro dropped its 1 million token context window earlier this year. The argument goes like this. If you can fit an entire code base, an entire customer support history, or an entire year of documents into a single prompt, why would you ever build a complex multi-step agent? Why bother with orchestration frameworks, memory systems, tool loops, and all the operational overhead that comes with them when you can just stuff it all in? Sam is back with me today. Sam has been building and evaluating LLM architectures for about 3 years now, and he had strong opinions about this one the first time I mentioned it. Sam, welcome back.
Thanks, Alex. Yeah, this one is interesting because the debate is being had in the wrong frame. The question people are asking is context window versus agents, as if they're competing solutions to the same problem. They're mostly not. But I want to be fair to the pro-context argument first, because it's not stupid. There are real scenarios where a massive context window genuinely does replace what you'd have needed agents for 18 months ago. And if you're in one of those scenarios, and you're building a 6-component agentic pipeline when a single long context call would work, you're paying a real complexity tax for no reason. So let's be honest about both sides.
Let's start with what 1 million tokens actually means in practice. I think a lot of people hear the number and don't have a good intuition for the scale. What are we talking about?
So a rough rule of thumb is about 750 words per 1,000 tokens, which makes 1 million tokens roughly 750,000 words. A standard novel is 80,000 words. So you're talking about 9 or 10 novels in a single prompt. In code terms, Python files average maybe 200 to 500 lines. 1 million tokens gets you somewhere between 2,000 and 5,000 source files, depending on how complex they are. The entire Linux kernel source is around 20 million lines, so you're not fitting that, but a typical microservice backend. Comfortably. A medium-sized code base of 100 files, trivially. So the use cases where just put everything in context becomes genuinely plausible are things like document Q&A over a large corpus that fits in one call, code review across a full feature branch, legal or compliance analysis where you need to reason across hundreds of pages, and certain summarization tasks where you need global coherence. For those, it's actually a pretty compelling pitch.
Okay, so that's a real list. For those use cases, what's the actual argument for just using context instead of an agent?
3 things. First, simplicity. An agent is software. It has bugs, it has retry logic, it has state management, it has latency from multiple round trips. A single long context call is a single API request. There's an enormous operational difference between those 2 things. If your task has a clear end state and can be answered in one shot, the single call wins on reliability almost automatically. Second, coherence. When an agent breaks a task into steps and reasons across multiple calls, it can lose the thread. Each step only sees its own context. A single long context call sees everything at once and can reason globally. For tasks like read this 300-page contract and identify every clause that conflicts with clause 4.2, global coherence actually matters a lot. Third, latency. A single well-parallelized long context call can be faster than a sequential 4-step agentic chain where each step waits for the previous one. So simplicity, coherence, and latency. Those are the real arguments, and they're real.
Right, but there are problems with long context that I've seen come up a lot. The one I keep hearing about is something called lost in the middle. Can you explain what that actually is?
Lost in the middle is a phenomenon that Stanford researchers documented in 2023, and it's held up across model generations since. The finding is that when you give a language model a very long context, its ability to use information degrades depending on where in the context that information appears. Models are consistently better at using information from the beginning of the context and from the end. Information buried in the middle gets missed or underweighted. The effect was measured with tasks where the answer was a single document in a list, and models performed dramatically worse when the relevant document was in the middle of the list versus at the start or end. Now, model providers have been working on this. Gemini has made genuine progress with a technique they call differential attention. But as of early 2026, the effect has not been eliminated. It's smaller than it was. It's not gone. For tasks where you're asking the model to find a specific fact buried in the middle of 800,000 tokens of text, you are relying on an attention mechanism that has a known systematic weakness at that exact task. That's not a great foundation for a production system.
There's also the cost dimension. I've seen some math on this that surprised me. Can you walk through what happens to your API bill when you start sending million token prompts at scale?
The cost math is where the just stuff it all in strategy hits a wall in most production scenarios. Let's use Gemini 2.5 Pro as the example because it's the flagship long context model. At the time of recording, the input cost is roughly $1.25 per million tokens for prompts under 200K tokens, and $2.50 per million tokens for prompts over 200K tokens. So a single million token call costs $2.50 in input tokens alone, before you count the output. Now, if you're doing this once, fine. If you're doing this for every customer interaction in a customer support system that handles 10,000 queries a day, you're looking at $25,000 a day in input tokens. $750,000 a month. Compare that to an agentic approach where a retrieval step pulls 3,000 relevant tokens and passes them to a reasoning call. At $3 per million tokens for a high-quality model, that's about a penny per query. 10,000 queries a day is $100 a day. The difference is not 10x, it's 250x. Long context at scale is an expensive solution to a problem that retrieval-augmented generation often solves for a fraction of the cost. You have to be honest about that trade-off.
Okay, so for document Q&A and one-shot analysis, long context makes sense. For anything at scale with repeated queries, the cost breaks it. But what about the argument that agents are about more than just information retrieval? What do agents do that a long context call structurally can't do?
3 things that context windows cannot replace. First, actions. A context window is a read operation. An agent can write. It can call APIs, run code, modify files, query databases, send emails. The entire value proposition of AI agents in production is that they take actions in the world. A bigger context window doesn't make a read operation into a write operation. Second, state persistence across time. A million token context window holds a million tokens right now, in this call. The next call has no memory of the previous call unless you explicitly put it back in, and then you're back to managing memory anyway. Agents with proper memory systems can maintain state across days, weeks, months of interactions without resending the full history every time. Third, parallelism. An agentic system can spawn subagents to work on sub-problems simultaneously. If you need to analyze 50 customer segments in parallel, an orchestrator that fans out to 50 concurrent calls and merges the results will finish in one round-trip time rather than 50. A single serial long context call can't do that. So, actions, persistent state, parallelism. Those are the 3 things that remain irreducible arguments for agents regardless of how big the context window gets.
So we're not actually in a context versus agents world. We're in a world where the two can combine. What does that look like in practice?
The most powerful architectures I'm seeing in 2026 are context-rich agents. The orchestrator is an agent. It can use tools, maintain state, run subtasks. But the individual reasoning steps use significantly larger contexts than they would have 2 years ago. Instead of chunking a document into 2,000 token pieces and doing 10 RAG retrievals, you might pass 50,000 relevant tokens to a single reasoning call. You get the coherence of long context on the relevant material without the cost of sending irrelevant context for every query. The memory layer handles what happened 3 sessions ago. The context window handles what you need to reason about right now. The action layer handles what needs to happen next. Each tool is used for what it's actually good at. That's the synthesis. It's not context or agents, it's context-aware agents.
If someone is building an LLM system today in 2026, and they're trying to decide where to start, long context call, agentic pipeline, or the hybrid, what's your recommendation?
Start with the simplest thing that could work. If your task is one shot, has a defined input and output, and the information you need fits comfortably, under 200,000 tokens, try a single long context call first. Measure it, evaluate the quality, check the cost per query. If it works and you can afford it at your query volume, use it. Complexity is expensive. Simplicity is underrated. If you need actions, anything that writes or calls external systems, you need agents. If you need state across multiple interactions, user context, conversation history, evolving knowledge, you need a memory layer. If you need to process more information than fits in one call at a cost you can afford, you need retrieval. These are not philosophical positions. They're answers to specific questions about what your system needs to do. Let those requirements drive the architecture, not the other way around.
I love that framing. The debate only seems binary when you're trying to pick a team. When you're trying to build something that works, the answer is usually, it depends on what you're actually trying to do, which is the right answer even if it's a boring one. Sam, thank you, this was genuinely useful. For everyone listening, we'll link to the Stanford Lost in the Middle paper and some Lang graph resources in the description. And we're covering more of this territory on the Amtalk Soft blog, links in the description there too. If you found this useful, subscribe so you don't miss the next episode. Sam, see you next time.
Thanks, Alex. Build the right thing for what you need. See you next time.